All right, so today we're going to be talking about E1, and basically it is the same reaction as E2, right? You're going to have a leaving group, you're going to have an adjacent hydrogen, and we're going to form an alkene, which is just a double bond, right? So what does an E1 reaction need? So in this case, unlike E2, we don't really need a strong base. So not so strong base. What is an example of a not so strong base? Think about water, H2O, methanol, so CH3OH, things like that, right? Protonated solvents tend to be pretty weak bases, okay? And that's all we need. Another thing we need is a good leaving group, just like E2. Good leaving group. Another thing we need is carbocation stability. So C plus, carbocation, stability. So what's the order of carbocation stability? What carbocations are more stable than others? It goes tertiary, then secondary, then lastly primary. And generally speaking, a primary carbocation formation is not going to go through an E1 reaction. Okay, so if we have a primary alkyl halide, don't automatically assume E1, lean toward E2. It's going to more readily go through an E2 reaction than E1 because it just doesn't form a stable carbocation. Okay, so let's start jumping into examples of this. Let's start talking about a compound that looks like this. This is somewhat similar to what we talked about in the E2 reaction. However, the Br is going to be placed somewhere else. Right now, the Br is going to be here instead. And let's see what happens. So the nucleophile the base I'm going to use for this is just going to be plain old water. Okay, that's our weak base. Okay, so that's how you can differentiate E1 and E2. E1, you're going to be using a weak base, something like water or methanol. Okay, so what's going to happen? We know that we're going to have a double bond form, but where's the double bond going to come from? So remember that E1 is actually going to be more selective than E2. E2 formed a Zaitsev and a Hoffman product. However, E1 will only form the product that is the most substituted alkene. Okay? So here are our options, right? We have hydrogens here, 1, 2, 3. We have hydrogens here, 1, 2, 3. Here, let me make that a little bit more pronounced. 2, 3, hydrogen, 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 and hydrogen, hydrogen, hydrogen. And then we also have hydrogens on this carbon right here, 2 of them, hydrogen and hydrogen, okay? So any of these hydrogens are sort of fair game to pull off. So what is the first step of an E1 reaction? First step is loss of a leaving group, right? Relate this to SN1. SN1, you had loss of a leaving group being your first thing happening. Same thing for E1, okay? So how that looks is that. Br is going to leave, it's going to take its electrons with it, and you're going to have this product formed. Positive charge right there, okay? Now all of your hydrogens are still there. Now we need to figure out what's going to be pulled off, right? So we again have hydrogens here, here, and here. So talking about more substituted alkenes, if we pull off a hydrogen here, the double bond that forms would be, I'll do this in blue and I'll do this in green. And I'm going to do it with dots to show you like these are possibilities. The double bond could form here, and it could form here, or it could form here. So which one would be more stable? Which one would be the more substituted alkene? If this alkene formed, then how many R groups do you have on this alkene? You have 1, 2, and on this part you have none, right? What about this one? You have 1, 2, and on this side you have none. So this alkene has 2, that alkene has 2. What about this one? This one has 1, 2, and 3. So that's the more substituted alkene. Therefore, that's going to be the product that forms. So then, in that case, which hydrogens do you pull off? You pull off these hydrogens right here. Okay? So with that, carbocation formed already. H2O, the lone pairs on oxygen, one of them is going to come in to take this hydrogen, and you're going to form that double bond, and what your product will look like is this. Double bond there, just like that. Okay? So that's the basic mechanism and reaction for an E1 reaction. So what about this whole carbocation stability thing? Where else did this sort of like give us a real pain, right? Rearrangements. So how can rearrangements occur in this case, just like SN1 reactions? So it all depends on if we can have a more stable carbocation. So here in this example, I'm going to talk about structure that looks something more like this. And we have a Br there. This is pretty similar to the structure that we worked with the E2, but this has a little twist on it, okay? Also, keep in mind that we're going to be working with a weak base, and that's going to be the identifying feature for this. So H2O is going to be our weak base. And what can happen here is, first step, of course, is loss of a leaving group. And then what do we have? We have our carbocation that forms. It's going to look like this, positive charge right there. And then what? Is that the most stable carbocation that we can get? It's secondary. Is that stable enough? Sure. However, can we make it more stable? Yes, we can. So how do we do that? We take one of these methyls and do a methyl shift. So the methyl shift is going to look like this. You take one methyl and you move it over there. Okay? This shifts our positive charge to this side, so that way it goes from being a secondary carbocation to a tertiary carbocation. So what does that look like? Two methyl group there, positive charge right there. So that's our methyl shift that happens so that we can have a more favorable carbocation, right? So now our base is going to come in and pull which hydrogen, right? It's going to pull this hydrogen right here because this will form the more substituted alkene, right? We already established with this example, if we pull one of these hydrogens, we only have 2 R groups. If we pull off this hydrogen, we'll have 1, 2, 3, and 4 R groups on our alkene, right? This is what our double bond is going to look like. I'll do this in orange. Dotted line to show you what the alkene will look like. That's what it's going to look like, right? So again, 1, 2, 3, 4 R groups instead of what we had here with 1, 2, because that's exactly what it's going to look like over here too. So let's draw that out. So H2O is going to come in, pull off this hydrogen. Hydrogen is going to form that double bond, and that's it. That's step 2. Step 2 is done, and our final alkene is going to look like this. And don't forget your methyl group right there. Okay? So that is how carbocation rearrangements can happen with an E1 reaction. So you have to keep that in mind when you're going through these practice problems where these rearrangements can occur. Things that can rearrange are methyl groups and hydrogens, okay? Primarily, the first thing, if you can move a hydrogen, like in this case, we didn't have a hydrogen present to move it. But if you do have a hydrogen present, move that before you move methyl groups. They have a higher priority, they're easier to move, they're easier to shift. So that happens before methyl groups happen. But if we don't have hydrogens available, then exactly what I did here happens first. And that's that. So that's E1. And then next video, I'm going to go over how to determine if something is going to go through an SN1, SN2, E1, or E2 reaction.